Hello and welcome back to Math with Mrs. Becker. This is Precalculus, and today we are just going to look at the introduction to mathematical patterns, which is Chapter 1, Section 2. Visual patterns exist all around us, and many inventions and discoveries begin as ideas that are sparked by noticing these patterns. A sequence is an ordered list of numbers. So again, when you have a list of numbers that is in a specific order, it is called a sequence. Each number in the list is called a term of the sequence. An infinite sequence is a sequence with an infinite number of terms. What that means is it does not have a stopping point. It continues forever and ever and ever. An example of an infinite sequence is positive even numbers. You can go 2, 4, 6, 8, 10, 12, 14, 16, 18, and you can keep going and going and going. There is not a stopping point to the number of positive even numbers. The 3 dots at the end of a sequence, this indicates that that same pattern continues for an infinite number of terms. Special notations that we are going to work with when working with sequences in general. When they talk about the first term, it looks kind of like a U with a little 1, like a sub 1. This indicates that is the first term of the sequence. So it only makes sense that the second term would have a little 2. A term in the nth position, meaning third, fourth, fifth, sixth, whatever position it is, that's the little number that you will see here. If you want to talk about the term that occurs prior, okay, just one term before, it's U sub whatever term you're on minus 1, because that will bump you to the term before. Okay, here's just a little visual exercise. Make observations about the pattern suggested by the diagrams below. Then they want us to continue the pattern by drawing the next 2 diagrams. Okay, me being a math person, the first thing that I always do is look at the number, okay? This is going from 1 to 3 to 5. So they want us to notice the pattern. Well, the first thing I notice is that every single time they're adding 2. So I need to figure out where the heck are they adding these 2, okay? I think it's going to be easier to recognize as we end up with more circles. And so if I have this diagram right here, there was 2 on the top, on the next one there's 3. There's 1 single, but here there's 2. So what I think happens is I think they're going to add 1 more circle on the bottom and 1 more circle to the top. So let's try that and see what happens. They want us to write out the next 2 diagrams. So if I were to add 1 more on the bottom, I'd have 1, 2, 3 circles. Here I have 3, so my top would have 1, 2, 3, 4 circles. 1, 2, 3, 4, 5, 6, 7. 7 circles. Does that follow the pattern of plus 2? Absolutely, because it's 1, 3, 5, 7. So if I do that again, instead of having 1, 2, 3 circles, 1, 2, 3, 4 circles, because I added 1, my row on the top had 1, 2, 3, 4. So now I would have 1, 2, 3, 4, 5. So if I count them 1, 2, 3, 4, 5, 6, 7, 8, 9, this pattern would have 9 circles. Okay, so that's just a skill that's really helpful. If you can look at diagrams, whether you are looking at the drawings to figure out the pattern, looking at the number of circles to try to see what the pattern is, that's just a skill that's really going to help you as you move through your upper level math courses. Okay, one more little idea for just our introduction here. A sequence is a function. Remember, functions means that the x value can occur only one time. The reason this happens is because each input, each x, corresponds to exactly one output. The domain of the sequence is a subset of integers, okay? The range is the set of the terms. And so what they're saying here is our sequence, okay? Our input would be 1, 2, 3, 4, 5. This is called our domain. This is simply just numbering the terms. It's saying the first term is 1, the second term is 3, the third term is 5, the fourth term is 7, the fifth term is 9. That's what they mean by your domain. Your range, those are the y values. That's your outcome. Those are the actual terms from the sequence. The cool thing is, looking at it this way, you could visualize this as ordered pairs. So 1 goes with 1. The first term is a 1. The second term is a 3. The third term is a 5. The fourth term is a 7. The fifth term is a 9. When you have ordered pairs, you can actually graph the terms because the domain of a sequence is discrete. That means you're not including any values in between. If you were to connect these points, then like 1.1 would be included, 1.2, 1.3, all of those different values in between 1 and 2. So if you are graphing a sequence, they are disconnected points on a grid. Let's go ahead and graph and see what the sequence looks like. So my x values, I'm going from 1 to 5. So 1, 2, 3, 4, 5. That's called the domain. Your y values, I have to go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now discrete dots. So right one, up one, there's a point. Now you don't connect it. 2, 3. The third term was a 5. The fourth term was a 7. The fifth term was a 9. Now looking at the pattern, this appears to be a linear pattern. Okay, that's kind of cool. And that's just a little hint as to what's to come. So there is no homework for part 1. I just wanted to do a basic introduction for the day to get you thinking about sequences. Have a great day. I'll talk to you soon.